Okay, and in this video I'm going to show you a little bit easier how to compute the statistics and how to make a bar graph summarizing our results in just the alpha band here. So we'll go back to our original spreadsheets, and instead of averaging now over all of the people, over all of you, we're going to average over frequencies. And specifically we're going to average over the frequencies between 7 and 14 hertz, the alpha range. And we're going to compare the two conditions. And so we'll go down here under our spreadsheet, and we'll say that our condition is called closed, and we'll say that the average is between, we'll say it equals average of the values between 7 and 14 hertz. So now this is the average for a single person of their alpha power when their eyes were closed. And we can drag this across as well. And we can then see what the alpha power was for every one of the 51 people that did the study. So there's the eyes closed alpha power for all 51 people. And we can paste that same formula into the other spreadsheet. We'll rename it open. So now we have the eyes open and eyes closed values for each person. And we're going to take those over to this graph here. And we're going to say equals to the closed condition, and we'll say equals, and we'll click on this one in the open condition. And then we can drag these values across, and we're just going to copy those same values that are in the spreadsheet, 7.13, and it's going to paste them into this new sheet. And we have values that go all the way to AZ, I believe. And if we were to take it one step further, there'd be nothing there. So we don't need those values. So there's the 51 people that did the study, and it's their average value for when their eyes were closed and their average value for when their eyes were open. And so one kind of plot that we might like to put is called a spaghetti plot. And so this is a line showing for each person the difference between the two conditions. So I selected the data, and then I went to insert a line graph just like we did before, except now I'm going to switch the row and column data, and I'm going to delete this legend. So now here we have this big group of spaghetti strings, which are showing for each person with a single line what their average alpha power was in the closed and in the open condition. I'll let you add a label to the axis here if you want to include this plot and as title as well. And then you can see that most of these lines are sloped down, which means that we had more alpha when the eyes were closed than when the eyes were open. So we can compare that directly, and we're going to do that in a similar way to we did in the other sheets. We're going to get the count, the mean, the standard deviation, and the standard error, and we're going to make a bar graph. So here we can do a count just like we did before. We can select the data from B2 to AZ2, if I'm not mistaken. And we can do the same, or we can just pull that down to this column here. We can take the average of those values as well, from B2 all the way to AZ2. There's the averages, and we can also take the standard deviation. We'll use the sample standard deviation again, from B2 to AZ2. And we'll pull that down as well. And then the standard error, remember, is the standard deviation divided by the square root of the number of subjects. So there's our standard error in each condition. And one other thing we might want to look at here is the difference for every person between their eyes closed minus their eyes open. And we expect these to mostly be positive. We expect most people's to have more alpha power when their eyes are closed than when their eyes are open. So we could think about all these differences as well as being an important measure. And essentially those are the slopes of these lines here. So we can take these same summary statistics and compute those for the differences as well. When we see here's the mean and here's the standard error. So the mean is bigger than 0, and the standard error is small enough that the range doesn't have 0 in it. Let me show you what I mean by that. So let's take these 3 mean values and let's insert them into a bar graph. So we'll insert this bar graph like this. So here's the 3 conditions: eyes closed, eyes open, and the difference between them. We're going to add those labels just like we did on the other plot by selecting these 3 names from the start of the columns in this horizontal axis labels. And we'll see we got closed, open, and the difference. And of course we can add error bars just like we did before as well. We can select these error bars, go to more error bar options, go to custom, specify the values, and we'll specify these standard error values to be both the positive and the negative error bars. So there we have it. Here's the bar graph for each of our conditions. Looks like, as we expected, we had more alpha in the closed condition than the open condition. Here's the difference, and you can see that on average the difference is greater than 0. And most people's difference is above 0. Here's another way you could look at that. You could plot all these differences as dots on a graph. And so each of the row of the horizontal dimension here is a different person. And you can see that almost all the people's dots are above 0. There's only 4 or 5 people that had greater alpha power when their eyes were closed, when their eyes were open than when their eyes were closed. Everyone else had it in the predicted direction. So these are some plots you could include in your paper. Remember to put axis labels as well. And you could even try to combine these into a single plot. Some people plot their data like this. They squish all these dots like this, and they show that they all cluster above 0. And you could even put something like those dots near your bar graph. If you could line up the values of 0 and 1, you could show that here's the bar graph and here's all the dots clustered around that bar graph. So I'll let you play around with the graphs in Excel. The one last thing we might want to know is whether this difference was statistically significant, whether it was reliable. And so we can compute that in Excel as well. We can compute both the p-value and the t-statistic associated with our value. So here I'll show you how. We can press equals and say t-test, and then it says to pick 2 arrays of data. And so first we'll pick our closed condition from B2 to AZ2. Then we'll pick our open condition from B3 to AZ3. And now it has us pick how many tails we want to use. We'll pick 2-tailed. And the type. And here, type 1 means that it's a paired t-test, which this was. Each of these pairings was a single person that did 2 conditions. So I'll put type 1. The p-value is 3 times 10 to the negative 7th. So it's 0.000003 or something like that. The t-statistic we can compute by typing in t-inverse. The probability is the p-value. And the degrees of freedom is our number of subjects minus 1. And this is our t-statistic. So we would say that t with 50 degrees of freedom is equal to 5.9. And then we can say that the p is equal to 0.000003. which means that we found a very reliable difference between the eyes open and eyes closed. Remember, when we report our statistics, we probably also want to report the means for the eyes closed and the eyes open. So we might write in our paper something like, the eyes closed condition had greater alpha power. Mean equals 5.74. SD equals 1.54. Then the eyes open condition, where the mean was 5.37 and the SD was 1.51. And then we would show the statistics in that sentence as well. So this is how you might write out the results of our study. In prose, you could probably reword it to be a little bit better as well. So I think that's everything. Here's the p-value and the statistic. Oh, maybe I'll show you one more thing, which is that you could get the same result by comparing the differences between each person's conditions to the null hypothesis of 0. So here I'm putting a row of zeros, and I'm going to take my t-test, and I'm going to use the 5th row here. So I'll say from B5 to AZ5. And I'm going to compare that to B6 to AZ6. And I'll use two tails and a paired t-test as well, and show you that you can get the same value. So those tests are equivalent. And we can do the same thing for the t-stat. Okay, so I think that's everything you would need to make some nice plots about our data and to compute the statistics and write them out in the paper. Let me know if you have any questions over email or Twitter.